Hey guys, it's Miss Johnson here, and I'm here to bring you your notes video for our learning target of solving compound and absolute value inequalities. Compound inequalities and absolute value inequalities, which actually end up being compound inequalities. Up at the top of your notes page, the first example says one test that used to determine whether a patient is diabetic is called the glucose tolerance test. Patients start the test in a fasting state, meaning they have to have had no food or drink except for water for at least 10 hours, but no more than 16 hours. Write an acceptable number of hours, H, for fasting using an inequality. So we need to figure out what the range is. Basically, we're going from 10 hours up to 16 hours. So we know we need to be greater than or equal to 10 and less than or equal to 16. Well, I can write those out separately. I could have h is greater than or equal to 10, and I could have h is less than or equal to 16. But since this is something where we want to be between this range, we can actually take these two and put them together. I'd have 10 is less than or equal to h, which is less than or equal to 16, because what that says is h is in the middle of 10 and 16. Now both 10 and 16 are included, so that's why I used the greater than or equal to and less than or equal to symbols. But that would be an inequality that showed the two together. Compound inequalities are when we have more than one inequality joined together, just like a compound sentence is like two phrases put together. So it consists of two inequalities joined by the word and or the word or. And inequalities are true if and only if both inequalities are true. So you have to have both. That's one of those between things, kind of like the one we just looked at. They had to be greater than 10 and they had to be less than 16, so both had to be true. This is an and inequality. It's going to be between the two circles there. Or inequalities could be either or. It could be one or the other and doesn't have to be both. It actually can't be both. So in this case, I'd have x is less than or equal to 1 or x is greater than 4. Those arrows go out like you see there. And the middle is the part that's left out. So you've got and or statements. So let's take a look at our first example. It says solve for x and graph the solution on a number line. We have an and inequality here. The x is in the middle of two inequalities. This is our compound statement. There's a couple ways you can think of this. You need to think of this as one of the inequalities and also think of this as the other. Now some people like to write them out separately. 13 is less than 2x plus 7 and 2x plus 7 is less than 17. And then solve them separate, and we can do it that way. So we would have to subtract the 7 here, and we'd have 13 minus 7, which is 6, is less than 2x. Then divide by the 2. I'm dividing by a positive, so my symbol stays the same. And there I have 3 is less than x, or in other words, x is greater than 3. And then we'd solve this one over here, subtract the 7. I have 2x is less than 10. Divide by 2. Again, I'm dividing by a positive, so it stays the same. So I have x is greater than 3 or less than 5. Now that's one way that we can do it. Some people are okay, and once you get better at these, or you've done a few of them, or if you've done them before, some people are okay with doing them together in the same, just as they're written in the same sentence. So I could do something like this. I'm subtracting 7 from the middle. I need to do it from here and from there as well. So I get 6 is less than 2x, which is less than 10. And then I divide by 2. I do it from both sides. So I have 3 is less than x, which is less than 5. They end up giving you the same answer. It does not matter to me which way you use. Those are just two different varieties. If I were to graph this, I need to draw myself a number line here. And I want to be between 3 and 5. So I'm going to put 3 down here. Here's my 4. Here's my 5. Both of them have open circles, and I want to be above 3 and below 5, so I'm going to shade in between. There you go. Let's take a look at 1b. I have 8 is less than or equal to 3x minus 4, which is less than 11. I'm just going to solve it from the middle here. So I'm going to add 4 to both sides. So I end up with 12 is less than or equal to 3x, which is less than or equal to 15. and then I have to divide by 3 from all sides, all parts. 4 is less than or equal to x, which is less than or equal to 5. So now I'm between 4 and 5. Here's my number line. I'd have 4, 5. They're closed circles this time because of the less than or equal to signs. So closed circles, and I'm still shading in between. All right, why don't you guys take a look at part C on your own? You can go ahead and pause the video and take care of that. Take note that this is an OR inequality, so we're just going to solve the two separate and graph them on the number line. Let's go ahead and move on to the back where we have some absolute value inequalities to look at. Let's just review. Absolute value is the distance from 0 on a number line. So the absolute value of 7 is 7 because 7 is 7 units from 0. Absolute value of -2 is 2 because -2 is 2 units from 0. When I have an equation like this, an absolute value of x is equal to 3, that's where we can split it into two equations and have x is equal to 3 and x is equal to -3. So those are our equations, but now when we have an inequality, what does that do for us? So in part D, I have the absolute value of x is less than 4. So I'm still going to split this off, but what happens is when I split this into two equations, I end up with x is less than 4, which is what we started with. When I flip the 4 to be negative, I also have to flip the sign. So I have x is greater than -4. What that's like is when you multiply or divide by a negative number with inequalities, we have to flip the symbol. And that's essentially what we did. We multiplied it by a negative to turn it into -4. Since I multiplied it by a negative, I have to flip my sign. So flip your sign when you change it to a negative. Now I can graph these together on the number line. So on my number line, I want x is less than 4 and x is greater than -4. So this is actually an AND statement. I have -4 down here. I want x to be bigger than that, but I want it to be smaller than 4. This is AND. And by the way, all less thans for absolute value turn into AND statements. So I have a -4 is less than x, which is less than 4. Here's my number line. I've got -4 down here. I go up to 0. Here's my 4 up here. These are open circles, and I want them both to occur. I want it to be greater than -4, but I also want it to be less than 4. So I'm in between. All right, why don't you go ahead and work on part E on your own. Absolute value of x is greater than 4. Think about what that looks like. Don't forget to flip that sign when you change it to a negative. Okay, and here's those symbols if you want to take note of those. All right, we're going to go ahead and stop our video at that point. Please remember to jump back to Schoology and take the Schoology quiz that goes along with the notes for solving compound inequalities. Thanks for watching and have a great night.